স্ক্রিন দেখা যাচ্ছে আমার? সবাই দেখতে পাচ্ছ? আমি স্ক্রিন শেয়ার করেছি, দেখতে পাচ্ছ সবাই?
Yes, sir.
আচ্ছা, right. So, well, today we'll not discuss any new topic. Rather, we will review uh, depending on your confusion, concern, query, etc. So just feel free to ask questions if you have.
স্যার পাইপলাইন হ্যাজার্ডের একটা প্রবলেম ছিল।
বলো।
স্যার এই যে পাইপলাইন হ্যাজার্ডে যে এই যে রিড আফটার রাইট এন্ড রাইট আফটার রাইটের যে প্রবলেমটা একটু ডিসকাস করলে ভালো হয়।
Okay. So we always discuss with reference to some instructions when we talk about hazards. Let's say this is T0, T0, uh,
আপু হ্যাঁ খাইছি হ্যাঁ ওরা খাইছি ঘুমাইছে আচ্ছা ঠিক আছে আচ্ছা
so if we have two instructions, like this, it means, let's say this is the result field of first instruction, right? And the result is used as operand in the next instruction. So it means the second instruction, it depends on result of first instruction. When these instructions should be processed on a pipeline architecture, so there would be a hazard, and this hazard is called true dependency. True dependency. We also have another name for this hazard, and the name is chosen in such a way that if we use that If we follow that one, we can avoid this one. It means in order to avoid this hazard, well, this operand, the operand for the next instruction, I mean this one, operand for the next instruction, this operand, we should read this one, we should read this one, read this one after the write operation. Write means after this result is saved. So save means write. So the hazard is called read after write. বুঝতে পারলে? Is it all right?
Yes, sir.
So this is one kind of hazard. And we also have other hazard, data hazards, usually applicable in case of processors allow out of order execution. For example, let's say if we have instruction like this, if we have instruction like this, if we have instruction like this. Now look at this pair of instruction. And what do you do here? We just read. We just read, right? And what do we do here? We just write. So if it happens so, the same register is being read in one instruction, and in the succeeding instruction, we save result to the same register. And if this instruction is processed ahead of this one, there will be a hazard. If this instruction is processed ahead of this one, in case of processors allowing out of order execution, then there would be hazard. So we have a name for this one, and this hazard is called anti-dependency. Anti-dependency. And we have another name just to avoid this hazard. And what is it? We must write after read. Write after read. Write after read. It means this instruction should be processed first, followed by this one. If a register or memory locations is used in consecutive instructions, if it is read first, followed by write. So this is another name for this dependency. We call it write after read. And there's another type of hazard. For example, let's say if we use something like this, let's say T0 S1 S2, and we have another instructions. Let's say T0 S3 S4. So look at this pair of instructions. So in this example, or in these instructions, the same register is used to store the result. Well, it will hold the sum of this one, and in the succeeding instruction, the same register is used to hold the result of this. Now, if this instruction is processed ahead of this, there will be a hazard. In processors allowing out of order execution, and we have a specific name for this one, and it is called output dependency. Output dependency. We have another name for this hazard, and the name is, well, we must write the operand for second instruction. I mean, we need to write this result. We need to write this result after we write this one. After we write this one. So its name is WAW. Right? So these are three types of hazards: true dependency, anti-dependency, and output dependency. We have other names for these dependencies as well. Read after write, write after read, and write after write. Is that clear?
Yes, sir. Thank you.
No problem. Right, so any more question from anyone?
So LFU আর LRU অ্যালগরিদমসটা আবার একটু দেখা যাবে?
Sure. So in case of cache mapping, especially in associative mapping and set associative mapping, let's say in case of fully associative mapping, let's say this is so this is the RAM, and we have blocks numbered 0, 1, and it goes on, and finally we have a block j equal to m minus 1, assuming there are m number of blocks. So this is RAM, and in case of, so let's say this is your cache memory, and cache is not divided into blocks as well, right? Cache memory is also divided into blocks. Cache is also divided into blocks or lines, whatever you say. Let's say I, 0, 1, and this is our m minus 1. So in case of associative mapping, any block of RAM would be copied to any line of cache. Any line of cache. So when the cache is full, let's say the cache is full. The cache is full. Full means, well, different lines will hold different blocks of RAM. Different, let's say it holds 5, it holds 9, it holds 11 or 125 for some reason, and so on. this one holds, let's say, 92, etc. Now, if there is a cache miss, if there is a cache miss, if there is a cache miss, always a new block must be copied from RAM into cache. A new block must be copied from RAM into cache. RAM into cache. Now the question is how to make room for this new one. Well, the answer is very simple. We need to replace a block from cache. We need to replace a block, a block of RAM from cache. Now, how to do that? We talk about two algorithms. One is, we call it least recently used, following the principle of locality of reference. Another is least frequently used. So you look at the names of this algorithm. One says least recently used, another is least frequently used. So depending on this, a block is identified which is used, less in recent time, and then least frequently. Frequently means access number of times any block is accessed by the CPU to read data or instruction. So these are the two algorithms, mainly following the principle of locality of reference. Okay. Now, to implement this algorithm, we need to keep information about the thing, the algorithm is based on. So we need to count the instances, or we need to count how frequent a block is used in recent time in case of least frequently used. In case of least recently used, we need to keep an account which blocks are recently used, or which block is recently, used and which one is not being used. So which one would be replaced? Least recently used and least frequently used. So based on the comparative assessment, a block should be identified and that should be replaced. So in order to implement these algorithms, we need to keep information about how different blocks are being used. Is that clear?
Yes, sir.
Okay. So any more question from your side?
Yes, sir.
Yes.
Sir,
Bolo?
sir, can you please visit boot algorithms lecture slide? Sir, sir, how does that Booth's algorithm work, sir, in that multiplier and Booth recorded form, sir?
Yes.
Uh,
So we
Not
will,
this one, sir.
yes, we will refer to this, let's say we will bring all these three together. So that will help you to understand how does it work. Let's say we intend to multiply 7 by minus 6. So the binary equivalent of this one is 0, 1, 1, 1. Well, for 7, for minus 6, it is, we first take the binary representation of this one, and then we take the 2's complement, 1, 0, 0, 1, and then we add 1. So finally it is 1010. This is in fact the binary equivalent of minus 6, right? To implement this one, well, this register should be loaded with 0. This register should be loaded with 0, 1, 1, 1. So this is the content of this one. It will hold the multiplicand, right? And this register will be initialized with 0, 0, 0, 0, 0. This one would be initialized with the multiplier. This time it is 1, 0, 1, 0. And we have another flip-flop that is initialized to 0 at the beginning. So this is the initialization. Now, if you follow the flow chart, right? This is what we call initialization, right?
Yes, sir.
And then, well, this control unit will check these 2 bits, and the boot code is formed. Boot code for this is, let's say, if you look at the slide, this is the boot code, right? This is the boot code. It means when there is 0, 0, 0, 0, it means no strings of ones. So no addition, no subtraction. It's only shift right, arithmetic shift right, okay? In case of 0, 0, it's only arithmetic shift right. So remember, when we shift these 3 units together. These 3 units together, right? It means, well, this bit should be shifted right. This one is shifted right, This one is shifted right. This one would be shifted here. This one would be shifted here, shifted here, shifted here. This one would be shifted here, and initial content would be discarded. Now, when we talk about arithmetic shift, we preserve the sign bit. Sign bit means this bit is
Most
fed back.
significant.
Yes, this bit is fed back. We don't insert zero from the left, remember. In case of arithmetic shift, we don't insert zero. We don't do that. Usually, in case of any shift operation, right shift, we insert zero from the left. But in case of arithmetic shift, we don't do that. We in fact, feed this most significant bit to that position. This is how it is different from the logical right shift. Okay.
Yes,
So
sir.
now, well, the content of this adder, that would be initially, that would be zero, right? Since we add, we don't do any add or subtract. So this is, you can see in the table. You can see in the table, right? So we talk about initialization. You check this one. Sorry. So now you can check this table. Contents of different registers at different cycles. So this is the initialization step. And then at the beginning, since these two control bits are zero, right? So there is no add, addition,
Shift
or
right.
subtraction, only shift right. And because of that, now the last two bits, these two bits will be last two bits. I mean, we are talking about these two. Well, it would be 1 0. If it is 1 0, you see this one. For 1 0, it would be subtraction. Subtraction followed by shift. Subtraction followed by shift operation. Right?
Yes, sir.
And in case of, and then we do the same thing. We always shift, but either we add or we subtract or we don't do any addition or subtraction in case of 0 0 and in case of 1 1. So you will find this in this table. For example, based on these two control bits, it is decided. You see this one, subtraction. A divided by M. A means the current content of this one. M means the multiplicand.
Multiplicand.
Okay?
Yes, sir.
So the
Sir,
content, yes.
sir, in exam, if we just draw the table with the flow chart and the circuit, is that enough, sir,
Hopefully
to
it is
explain?
enough. You need to draw, you need to reproduce this slide, for example. The hardware or, the block diagram, the flow chart, and the table. So you need to check the numbers and you need to prepare the table accordingly, right?
Yes, sir.
Yes, should be enough. But there could be a few short questions on these, just to test whether you understand it well, right? So that could be another question. But when we explain the Booth algorithm with an example, let's say given two numbers, so we would expect that you would draw the hardware, the flow chart, and the computation in its steps as we present in the table. Okay.
Yes, sir. Sir, do we have to show all the multiplication process, sir? Like
Uh,
the multiplier and multiplicand being multiplied?
no, just if you can generate this table, should be all right, as
Thank
you
you so
see
much,
here,
sir.
right?
Yes, sir. Thank you,
But
sir.
if we ask you, let's say, to explain, let's say in another question, if we ask you to explain the right shift or other algorithms we have for multiplication, right? So in that case, probably if we ask you to explain the right shift with an example, so there also you need to draw this diagram, the block diagram of the probable implementation and an example. Okay?
Yes, sir. Thank you, sir.
No problem. Any more question from anyone? Right. So uh, I just if you follow the Google Classroom, I made an announcement last night regarding your makeup. So I decide to arrange your makeup following your term final. So there is a break in between exams, right? So I intend to utilize that time. So the time would be a bit shorter. I mean, let's say we would complete your makeup within 40 minutes time or even less than that, right? So hope this will save your time, right? You will just prepare for this course once, uh, both for term final as well as for the makeup, right? Because you need to go through the whole thing since there will be a part in your term final. I mentioned earlier, it would be MCQ on the whole syllabus, right? So you need to go through the whole things, especially the critical points and other things. So is it all right with you? Because it would be extremely difficult to find another time for your makeup because you will be very busy with the exams and we just it would be really difficult to find time that would suit all, right? So considering this fact, I decide to utilize that time following your term finals. Okay,
স্যার মেকআপ মিডের সিলেবাসটা কি হবে?
it would be same. I also announced that one on the Google Classroom. If you follow that announcement, right, the syllabus would be same. If you see this one, right? Okay,
Yes,
same
sir.
syllabus. So carry on with your studies, and if you need any help, feel free to email me so that I can arrange office time to discuss your concerns or queries or confusions, if any. Right?
So, is there any possibility that if you could extend the time for meet, sir, not like 40 minutes, like at least 50 or 1 hour?
Uh, that would depend. That would depend on the situation. Like if you have time, then I don't have any problem with that. But if you have back-to-back exam, in that case, it would be, for those, we need to allow them to go to or prepare for the other exam. That could be arranged, right, during the exam time.
Yes, sir. So what about the quizzes, sir?
We will, I decide to arrange the quiz fast, so many students, those who, you know, may not require the makeup, so they can leave early. So after your term finals, I'll probably arrange one or two quizzes within the first 10 minutes, and then you can decide whether you will stay or not, right?
Yes.
So it is scheduled like this: your term final followed by quiz, and then the makeup. So it would be extremely busy day. Term final, quiz, and makeup. Okay,
স্যার আমার 1:40-এ পরের এক্সাম আছে, তো এর মধ্যে কি শেষ হয়ে যাবে সব
hopefully
নাকি আরো
so.
টাইম?
Yes. No, no, no. We will not extend it. We will not, we will not create any problem for those who have exams, uh, in the next time slot. So I'd be very careful about that.
ওকে স্যার,
Okay.
থ্যাংক ইউ। প্লিজ।
So we'll finish everything bit early so that you can, at least make up your mind for the next exam, right? Okay, so do you have any more question? Feel free to ask. Regarding your term final, I will announce the syllabus, types of questions, and the detailed guideline for your exam. So just wait for one day. I can announce tonight, or I'll announce as soon as possible, right? But it's likely, uh, you know, you have to answer one question from both algorithm, another question from the cache memory, cache mapping, as mentioned earlier, like this, right? So where is it? Cache, where is it? So I talked about the cache, right? So yes, so probably we'll ask you to solve a problem like this, okay? And there'll be another question on pipeline hazard. Just show the processing of some instructions having data dependencies and control hazards as well. So you need to solve it, right? So these are the three problems probably, you know, you need to solve. On top of that, few more short questions or some explanations I may ask you to, to, to do, right? So it would not be that difficult, I guess, because, just you can guess these three questions you need to solve. And on top of that, few more simple questions will be asked, right? Okay, so carry on with your studies. So feel free to ask, or, request for the office time. I will arrange it. If you need, you know, more than one office time, so don't hesitate to write. I will arrange it, right, at your convenience. So if you don't have any question today, so I thank you for attending today's online session.
Sir, can I give
Hopefully,
attendance?
yeah. Do you have any query,
No, sir.
Saif Mahmood?
না স্যার, আমি অ্যাটেন্ডেন্সটা
Yes,
দেওয়া
you can.
হয়নি।
Attendance. I did not record your attendance today, so I'll do it something. I'll check the uh, other records, and I'll also take some note during the exam time. Anyway, so thank you very much for attending to this class. Bye.
Sir, I had a question.
Feel free to ask.
স্যার আমাদের মিড টার্মের কোশ্চেন প্যাটার্ন কি স্যার মেকআপ মিডের কোশ্চেন প্যাটার্ন কি মিড টার্মের মতোই হবে?
মিড টার্মের মতোই হবে, তবে একটু শর্ট হবে, a bit
শর্টার
shorter.
ভার্সন।
Yes.
জি স্যার, থ্যাংক ইউ স্যার।
Okay. Any more questions from anyone? All right, see you then.
স্যার আমাদের স্যার মেকআপ মিড কি এমসিকিউ টাইপ
হ্যাঁ,
কোশ্চেন
বলো।
হবে? আমাদের স্যার মেকআপ মিড কোশ্চেন
মেকআপে কোনো এমসিকিউ হবে না। মেকআপে কোনো এমসিকিউ হবে না, but there would be a different MCQ that would be part of your term final. That would be part of your term final.
ওকে স্যার,
It's a
Got it.
separate exam. Okay?
ওকে স্যার।
Yes, sir.
Bye. Thank you very much.
Thank you, sir.
Thank you, sir. Assalamu alaikum.
থ্যাংক ইউ স্যার।
Bye. Bye.